Okay, so let's go ahead and go over this and then we'll start. So I'm just going to go ahead and highlight my like terms. So I've got an x to the fourth and an x to the fourth, negative x to the fifth, and negative x squared and x squared, an x, and then a constant. So that gives me 8x to the fourth minus 8x squared plus x plus 2. Yeah. So on the next one, I've got x to the fourth and x to the fourth, x and x, and then my constants. And then I have a minus sign here, which changes all my signs inside. So this is minus, this is minus, this is minus. So I get negative 7x to the fourth minus 2x plus 4. Beautiful. Let's see, x to the cubed, x squared, x, and then a constant. Again, I've got a negative here, so that changes all my signs inside. So plus, this is a negative, this is a positive, this is a positive. So I get, let's see, what do I get? Negative 4x cubed plus 14x squared plus 15x minus 1. And then the last one, same thing for me. Here's x to the 4, b to the fourth, b squared and b squared, and a b and a b, and then a constant. And it's plus, so I'm just going to do what it says here. So I've got 6b to the fourth minus 6b squared plus 0 minus 6. So there we go. Done. Okay. So most of you guys all got that right. Good job. I'm so glad you can add like terms and subtract like terms, more importantly. So good job. So now we're going to do a couple definitions. We're moving on to rational expressions. And we just have a few definitions here. A rational expression consists of a polynomial divided by a non-zero polynomial. Examples are 3/4, x over y, 9 over a plus b, x squared plus 7xy minus 4 over x cubed minus y cubed, 1 plus z cubed over 1 minus z to the 6th. Those are all rational expressions. So basically we're dealing with fractions everywhere and exponents everywhere today and, well, for this whole unit. The product of a rational function says if I have a over b times c over d, how do I multiply fractions? Well, I multiply, right? I multiply across this way. So I get a times c, that equals a times c over b times d, as long as b and d do not equal 0, because you can't have a 0 in the denominator. So that's the definition. I just multiply across. The quotient of a rational function means division problem. And it says for any expression a over b and c over d where b, c, and d cannot equal 0. So now everything but a cannot be 0 in this definition when I'm dividing, because what happens if I take divide a over b divided by c over d, how I divide fractions, you take that second fraction and you flip it. So instead of c over d, it becomes d over c, and then you times them together, just like multiplication, you multiply across, right? This way, so it becomes a over d equals b over c, okay? So those are just basic definitions. Now we're actually gonna do some problems. And I think we're just starting with simplifying first. So we just wanna simplify the problem. So if I'm looking at number 1, I'm just going to simplify. These are exponents and numbers. We're just going to make it simpler. So I know what goes into 24 and 30. 6. 6 goes into 24 and 30. Wow. 6 goes into 24 4 times, and 6 goes into 30 5 times. So I can make that happen. And then there's 3 x's on top. So I'm going to kind of, yeah, I'm just going to do this. There's 3 x's on top and 5 on the bottom. That means all 3 on top are going to go away, and I'll get left with 2 left on the bottom. And then there's 1 y on top and 8 in the bottom, and all on top are going to go away, and I get left with 7 in the bottom. So my answer should be 4 over 5x squared y to the 7th. Is there any questions on that? Okay. So if I look at number A, the 4 goes into 4, so they just make a 1, so they can go away, right? And then the x, there's 1 x on top and 2 on bottom. That means the 1 on top goes away, and there's 1 x left on the bottom. So that becomes 1 over x. Questions? Okay. So then the second one, or B, let's see, I'm going to still do the same thing. 2 goes into both of them. So 2 goes into 2 1 time and into 4 2 times. Okay. There's 2 x's on the bottom, which means there's going to be 1 x left on top. The y's, there's 2 y's on top, which means there's going to be 1 y left on the bottom. So I should get, what am I going to get? X over 2y. Questions? Awesome. Good job. So now we're going to go make it just a tad bit harder, just a little bit. Okay. So now we have to factor something out this time. So on number 1, I can't factor anything out of the top. So out of the bottom, I'm going to do this. I think out of the bottom, I can factor a 3. And that should leave this being 2x minus 3. And now I believe 3 goes into 3 1 time and into 21 7 times. Is that right? Yeah. So I should get 7 over 2x minus 3. And remember, when you're putting this into the chat, I just want to say if you put something like this into the chat, it should be 7 divided by parenthesis 2x minus 3 because it's divided by the whole thing. Okay? Just wanted to put that out there. Okay. And then in number 2, let's see. I think that I can factor out a 3 on the top and should get x minus 4, and factor out a 3 also and get x plus 5. So the 3's make a 1. So I should get x minus 4 divided by x plus 5. And when you're typing that in the chat, they should both be in parentheses. So this should be into the chat as you're putting it into a box. It should be x minus 4 divided by parenthesis x plus 5. Okay, so make sure you're putting your quantities inside of parentheses. Just there we go. So the first thing I'm going to do is factor. And that's the first thing we do all the time, is, if I can, is just factor. So the top is going to factor to x plus 8 and x minus 6 all over x plus 8. And then my x plus 8s are the same. So my answer is x minus 6. Okay. And then the second one, the top stays the same because there's nothing I can factor out of it. And the bottom, I think I can factor out a 7b, and then it factors to b minus 7, and I make a 1, so that would become 1 over 7b. Okay, questions? We okay so far? Awesome. Okay, so now we're going to get a little more complicated. And so the first thing we're doing when we it says, by the way, multiply and if possible, simplify. I'm just going to tell you, never multiply it together because then you'll never be able to simplify it, okay? So the first thing we're going to do is factor. Always we're going to factor it. It's the first thing we want to do is factor this. So I'm going to factor everything. Everything I can, I'm going to factor. So I'm going to start with the top. I'm going to start with this side and do the fraction, the top and the bottom of that side. And then I'll do the top and the bottom of the right-hand fraction and just factor. So I know on the top of the left-hand side, I can take a 7 out. So if I take a 7 out, I'm going to get 7 times x minus 2. Please tell me if I do something wrong. And then the bottom of the second fraction becomes x minus 2 times x plus 2. Or if I do something where you don't understand, please make sure you ask a question. Make sure you ask a question. Okay, so then that's times. And then I'm going to factor the top part. And so I know that 5 factors to 5 in 1. That's the only thing that multiplies to be 5. Oh, 1x, sorry, 1x. And the only thing that multiplies to be 1 is 1 and 1. So there's not any choices on this. So this is what it has to factor to be, because the only thing that multiplies to be 5 is 5 and 1. The only thing that multiplies to be 1 is 1 and 1. You can multiply it back out to make sure that you get 6x in the middle, but the 2 end terms should be correct. And just check it out. And then what can I factor out of 30? I think 5 comes out. No, 7 comes out of it. 7 comes out, and I get 5x plus 1. Now, once you have it all factored, what you're going to do is start making ones. And it doesn't matter which fraction it is. You're just going to make a ones. So I know I have a 7 and a 7. That's a 1. And I have an x minus 2 and an x minus 2. That's a 1. And then I have a 5x plus 1 and a 5x plus 1. That makes a 1. And then whatever is left is your answer. If I can't make any more ones, whatever's left is my answer. So my answer to this question is x plus 1 all over x plus 2. Done. Questions?
I just want to make sure when you put it in chat, both of them are parentheses.
When you're putting it into the chat box, yeah, you'd put them both inside parentheses. If you're just leaving it on your paper, you can just leave it like this, but because you're typing it in for me, if you just type it in without parentheses, I'm going to tell you why. Because what it looks like, you go x plus 1 divided by x plus 2. What it looks like, the only thing it looks like is a fraction is what? The 1 over x. So if you put it in parentheses, then it tells you it's the whole thing over the whole thing. Does that make sense? Okay. Yeah. Okay, so let's go ahead and go to the second one. Now the second one, I'm going to just kind of come down here and make a quick note because the first one is a cube. And I know it's been a while since we did some cubes, although you should have done some in your Delta Math yesterday. Oh, not yesterday, sorry. Monday or Tuesday, I don't remember. Probably Tuesday's Delta Math. But the cube rule, I'm just going to write it down at the bottom because it doesn't look like we're going to get down there. But the cubed rule, remember, says if I have a cubed, and that's a minus b cubed, I will get a minus b times a squared plus a times b plus b squared. Yeah, that's it. Okay, sorry, I did that from memory, and I'm pretty sure that's right. Okay, so I'm going to factor that x cubed minus 27 using this rule because 27 is, let me come back up here. 27 I can write as 3 cubed, right? So I can factor this to be, sorry, I should have left it there. I can't see it now. I can factor it to be x minus 3 times x squared plus 3x plus 9. And then the second one, let's see, I can factor out an x cubed, and I get x squared minus 6x plus 9 all over, let's see, I can factor out, what can I factor out of here? An x squared, and that leaves me with x squared minus 9 all over, that doesn't factor, so that's x squared plus 3x plus 9. Now I'm not really done factoring everything, but because I'm running out of room, I'm going to make some ones if I can, which I can. So this x squared minus 3x minus 9 and x squared, plus 3x plus 9, those are ones. I got the same thing on the bottom and same thing on the top. And then I have 2 x's on the bottom, which leaves me with 1 x on top. So now I'm going to factor everything else out because I have some more things I can factor, x minus 3, and then I have an x. And then this right here is going to factor to be, what does that factor to be, you guys? Oh yeah, x minus 3 times x minus 3. Yeah, that's right. So I had to think about it. All over x minus 3 times x plus 3. So a minus 3 and a minus 3 go away. And my final answer should be x times x minus 3 squared all over x plus 3. Whew, that's ugly. But sometimes you get ugly answers. So any questions? I would have done it all at one time if I would have had enough space, but I was running out of room. That's why I did it in 2 different spaces. Okay? Okay. So can I go ahead and go to the next page, or do you guys still need a few seconds to copy down? Okay. So I think the next 2 are yours. So you're going to do, well, there's 4. I'm going to try and keep all 4 of them up here for you guys on the screen. So let's do number A. And I think I can answer Emma Taylor's question at the end of this one or the beginning of B. It's the same thing. So there we go. I'm going to factor everything, right? Well, I'm not going to factor on this one. I'm going to, just by looking at it, I can already make a 1, right? If I just look at the problem, I can make a 1 because it has 2x plus 6 and 2x plus 6 in the bottom and the top. So I can just go, psh, psh. I don't have to factor that one. Might as well make it easy, right? And then I get x minus 7 over x plus 5. And then this is kind of similar to the question Emma just asked at the beginning of the next problem. And I think this is what you asked, right, Emma? Can I just go like that, right? And cross those off, right? So this is the question. So if I did that, that means the answer, no matter what x I put in, my answer should always be negative 7/5, right? That's what it says. It should always be negative 7/5. But what if, that's if x, but what if x equals 1? Will I get that answer? So if I plug 1 into this original equation and solve it, I should get negative 7/5 if that's my answer. But guess what? I don't. And that's why I can't cross this off. Because this right here, I'm going to rewrite it. I'm sorry. X minus 7 over x plus 5. This is not just x. This is x minus 7. I don't know what that value of x, because I don't know what the value of x is. It's x minus 7. And the bottom one is x plus 5. So it's a whole term together. I have to minus or subtract it, so it's not by itself. Does that make sense, Emma? So if I just cross off the x's, if I could just cross them off, that means no matter what x value it is, my answer would be negative 7/5. And that's not true. Does that make sense now? So this is not possible. Okay? And then, so same thing over here. I can't do that because I'd get the same answer. It's the same reasoning. So if I move over here and I factor, same thing. Look, I can factor here and here. I can make a 1 right off the bat by doing that. And then I have less factoring to do. So sometimes it makes it a little easier for me if I can make the 1s right off the bat, because I might as well make it easier if I can. And then I get 7x in x plus 1. I can't factor any lower than that, so that would be my answer. Done? Okay, any questions so far? Are we okay so far? All right, now I think the next two, I still have one that I can just get rid of. If I just look at it, I can get, that makes a 1, and then I have less factoring to do. Might as well make less work for me if I can, right? So the top factors to, what is the top factor to? Two numbers that multiply to be negative 5 and so 5 and negative 1, okay? And the bottom, two numbers that multiply to be, okay, so that would be 7 and 5. And I want a negative 2, so that's negative 7 and plus 5. So that goes away, and my answer becomes x minus 1 over x minus 7. Okay, questions? We okay so far? And then the last one, nothing in common. So I have to factor everything. And so the top, let's see, I can take out a 4x squared, and I get left with 3x plus 1. And then I can factor out a 3 and get left with x plus 10. Beautiful. And then the bottom, need two numbers that multiply to be 40, 4 and 10. So 10 plus 10 minus 4. Ooh, minus 4. Okay, and then again I can factor out a 3 and get left with 3x plus 1. So make ones. There's the 3, x plus 10 and x plus 10, 3x plus 1 and 3x plus 1. So I should get 4x squared over x minus 4. Okay, questions? Everyone okay? Awesome. So that's multiplication. That's it. Factor, 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 factor. If you can make ones first, do that because it makes it easier, right? But then we're factoring and then we're making ones. So we're factoring and making ones. We're not actually multiplying. Even though it says multiply, we're not multiplying. We're factoring and making ones, okay? So now we're going to go to divide. And there's one other step that we have to do when we're multiplying, and that's switch this. So the first thing I'm going to do is I'm going to switch that, oh my gosh, I can't even think. I'm going to switch that fraction. There we go. And then I'm going to factor. So I've got 25x squared minus 4 divided by x squared minus 9 times, because I'm going to switch them, x plus 3 all over 2 minus 5x. Okay, so now it's switched. Now it becomes times. I'm going to look to see if I can make any ones right off the bat. No, I can't. So I'm going to factor. Okay, so factor, 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 factor. So this top is going to factor to 5x plus 2 and 5x minus 2 times x plus 3. And then the bottom factors to x plus 3, x minus 3, and then the last one's going to factor to negative 1. I'm going to take a factor of negative 1 out of it, and then this becomes 5x minus 2. Okay, so now I'm going to make some ones. So I've got 5x minus 2 and 5x minus 2, x plus 3 and x plus 3. Beautiful. So my answer should be 5x plus 2 over negative x minus 3. Okay, questions? Everyone okay with that? All right, let's look at number 2. It looks beautiful too. So again, I'm going to do exactly the same thing. I'm going to flip them. So I'm going to flip this first. So I've got x squared minus 16 over x squared minus 10x plus 25 times x squared minus 3x minus 10 all over 3x minus 12. Now I do want to kind of talk about this. If you can factor this before you, and not rewrite it with the times and it flipped, then by all means, please do that. Because usually I don't put this step in, I just go straight to factoring. But I factor this, I do the second one and I flip it, I factor it flipped. Okay? So I would factor the bottom in the top and the top in the bottom when I factor it, so it becomes times. So I just kind of take that step out, but I want to make sure I'm doing all the steps for everybody who needs them. Okay, does that make sense? When I do the other ones after you've done them, then I'll show you how I do it in my head, which is kind of scary. Okay, so now I'm going to factor. So this first one factors to, let's see, x plus 4 and x minus 4. And the second one is going to factor to 5 and 2, negative 5 and plus 2. Yeah, that's negative 3. Okay. And then the bottom is going to factor to x minus 5 and x minus 5. And I can factor 3 out and get x minus 4. So now I'm going to make some ones. So I've got an x minus 5 and an x minus 5, x minus 4 and x minus 4. And that looks like it. So I'm going to get x plus 4 times x plus 2 all over 3 times x minus 5. Yeesh. Okay. And your answers stay in factored form. You don't have to multiply them back together at all. Okay? Okay. A little bit more time. Are you guys good? All right. So here you guys go for problem. Okay. So let's go ahead and do this. So I'm going to factor everything. I'm just not going to rewrite it. I know that I'm going to switch these two, right? But I'm going to factor and switch at the same time. So I know that it's 1 times 2x times x plus 1. Because what comes out of the bottom is a 2x, and I get left with x plus 1. And then I have x plus 1 times 2. Okay? So now I'm going to make 1. So the 2 goes away, and the x plus 1 goes away. And I get left with x. That's it. Emma, what you didn't do is you didn't factor the x out. Do you see that? You left x squared plus x. Okay. I saw you looking at it like, what the heck? Yeah, so you just didn't take the x out of this one here. Yeah. Okay, so on the second one, I'm going to do the same thing. I'm going to factor, and I noticed, just as I was doing this, that this is the same as this. So I don't know. Okay, so I've got 10n, and I'm not going to factor that because once I flip it, I've got the exact same thing on the bottom. So why factor it in order when it's just going to make a 1? So I didn't factor that part. And then times n minus 10. So to make a 1, those go away. But if you did factor them, both the factors would go away because no matter if you factor it or if you don't factor it, it's still going to make a 1. So I just didn't factor it because I realized that once I flipped this fraction, one was going to be on the top and one was going to be on the bottom. So why do the extra work? Right? That's all I'm thinking. So then this becomes 10n over n minus 10. And everybody got that one right. So good job. Okay? And then, let's see, then number C is a little bit harder because I got to factor everything. So I'm going to flip this and I'm going to flip this. So the top one factors 2. Let's see, what multiplies to be 24? Negative 24 adds to be 2. 6 and 4. So plus 6 minus 4. And then the bottom, I can take a 3x squared out. And I'm going to get left with x minus 1. Okay. And then I'm going to factor the bottom. So this will be x plus 6 and x minus 6. And then what multiplies to be 4 and adds to be negative 5, x minus 4 and x minus 1. So I make some 1. So I've got x plus 6 and x plus 6, x minus 4 and x minus 4, x minus 1 and x minus 1. So my answer should be 3x squared over x minus 6. Questions? All right, one last one. Okay, flip these and factor. So let's see, I've got r minus 4. And then 7 comes out, and I've got r minus 9. I think that's right. And then the bottom, I need two numbers that multiply to be 36 and add to be negative 13, negative 9 and negative 4. Yeah, that's right. And then what comes out of this would be 9r cubed, and that would be r minus 8. Yeah. Okay. So so I have r minus 4, r minus 4, r minus 9, r minus 9. And that looks like it. So I get 7 over 9r cubed times r minus 8. Done. Okay, questions? Emma, do you have a question?
No, I'm just really dumb, and for the past couple of minutes I've been like, what is she doing? And then I realized that you're doing the x method, but in your head.
Oh, yes, that's exactly what I'm doing, yes. Sorry, you could draw it out on the paper, and I'm just, oh, you mean when I say what multiplies to be this and adds to be this? Yeah, I'm just doing it in my head.
Like, what? And then I just had the biggest aha moment, so I'm texting my friend, and I'm like, I'm so stupid right now.
Yeah.
She's also doing that, so.
Yeah, I'm just doing it in my head. Sorry, I should have said that. My bad. Okay. Is there any other questions, you guys? Because that's it. You have a Delta math assignment today. I don't think it's too terribly long. So I guess I can pause.